Hello, this is Dave Barbano. This is a project report for Project 1, funded by the Dairy Promotion Board for the Northeast Dairy Center 2001 contract. This is the technology transfer report. I'm Dave Barbano from Cornell University. The objectives this year for this continuing project were to continue on microfiltration technology transfer. This is microfiltration of milk, to implement analytical methods for process control in dairy plants in New York State, and to continue with implementation of milk testing to enable improvement of milk composition and quality for dairy product manufacture. First, microfiltration technology transfer. Several companies use ultrafiltration for making whey protein concentrate, and recently, both within New York State and outside of New York State, we have plants that are working with milk UF. Recently, ultrafiltration has been used to concentrate milk fat and protein for both cheese making and fluid milk processing. Fairlife was the first to achieve widespread implementation of ultrafiltration for fluid milk product production. Recently, the Lactaid brand of fluid milk has introduced a line of Lactaid milks that are protein fortified by addition of UF concentrated skim milk. We have worked with both of these companies to help them implement ultrafiltration and troubleshoot membrane filtration issues. The use of ultrafiltration is the first step in the path to implementing microfiltration technology that does something a little bit different and beyond what can be done with ultrafiltration. The microfiltration, ultrafiltration of skim milk removes lactose, either part of it or all of it, and it concentrates all milk proteins, and it concentrates the calcium bound to casein, one of the major two groups of proteins in milk. These changes in terms of concentration improve the nutrient profile of milk by lowering the lactose content, increasing the protein content, and the calcium content. And the current commercial products are essentially in that format. However, when these products are given a very high temperature heat treatment to provide longer shelf life, these products develop undesirable sulfur, eggy flavors and aroma. And these aromas are particularly undesirable or objectionable to children in beverage milk products. Microfiltration, what differentiates it is it also delivers the same outcomes of ultrafiltration that are listed above, but it does one additional separation. The microfiltration concentrates the group of proteins in milk we call caseins, and it filters out the group of what we call whey proteins, or sometimes milk serum proteins, and removes those in the filtrate also. Why is removal of milk-derived whey proteins important from a filtered fluid milk innovation perspective? When whey proteins are removed by microfiltration and the microfiltration concentrates are processed using high temperature to achieve shelf stability of the beverage or the milk, they do not develop sulfur, eggy off flavors. This is a positive from a consumer liking perspective, particularly for children. We've been working with processors making prototypes of these MF concentrates to demonstrate this and to let them gain familiarity with the process and product. We've actually run a pilot scale microfiltration unit in a couple of factories in the United States. The second objective of implementing analytical methods for process control in dairy plants. Our research sponsored by the USDA Federal Milk Markets strives to improve chemical analysis methods for milk and dairy products. We're working to transfer and implement that knowledge and technology in New York State dairy processing factories. We've developed improved infrared prediction equations for measuring concentration of fat, protein, lactose, and many other components in milk and dairy products. In addition, we have also developed calibration standards for cream, condensed skim milk, various whey fractions and concentrates, UF and MF retentates and permeates. We work directly with most New York State dairy processors to help them utilize our calibration standards that we provide and help them implement the QC procedures using those standards and mid-infrared milk analyzers to improve product quality and process control in dairy product manufacture. The third is the implementation of milk testing to enable improvement of milk composition quality. So that's composition quality for dairy product manufacture. This is a little bit different. The new rapid milk testing parameters and their fatty acid measurement parameters called de novo, mixed origin, and preformed fatty acids, which many producers, milk producers in the Northeast are familiar with. The development of these were a spin-off from the milk method development work sponsored by the USDA Federal Milk Markets Labs to improve accuracy of fat testing. Initially, this testing was implemented by the St. Albans Cooperative and Agrimark in New England in cooperation with Cornell, and to test in terms of improvement of milk production, fat content, and protein content. The testing of milk from those farms is now done for the two co-ops at Dairy One in Ithaca, New York. And we have worked with Dairy One and implemented this testing for the fatty acid groups. And the availability of this data is now there for DFA producers, plus the St. Albans and Agrimark co-op members. We've also implemented this testing for Upstate co-op and Cuga marketing producers also. So this provides some herd management data, both feeding management and in the future, some herd health management information. What is the benefit of this milk analysis technology? The first benefit was to USDA Federal Milk Markets because the technology allowed them to further improve the accuracy of milk payment testing for fat. And this has been implemented all across the United States in their laboratories. The second benefit has been to milk producers by enabling the use of the de novo, mixed origin, and preformed fatty acid information to improve feeding and going forward to better manage health of transition cows by rapid identification of cows that are having a health issue. So this is really a farm management type of application of this, and we've spent quite a bit of time teaching and working with dairy nutritionists in New York State, the Northeast, in how to use this information. And now it's spread within DFA. We've done some remote workshops for DFA field people, and there is also testing going on, this type of testing going on in the Western US, and we have some labs in Europe starting to do this now too. We think there will be a third benefit for dairy farmers and processors in the future with this testing. Now that we have the ability to rapidly measure the de novo fatty acids. These are fatty acids made within the mammary cells from forage breakdown products, from acetate and butyrate produced in the rumen fermentation of high quality forages. We think that these test results on de novo fatty acids and the concentration of de novo fatty acids in milk fat and the proportion of them in milk fat, these may be important in dairy product flavor and physical properties. And from my perspective, most importantly, they may have added value. And this is something that looking forward in the future, trying to do research to identify whether higher levels of these fatty acids, which we can feed for in milk production, produce better flavors in cheese, better physical properties in high fat products, and whether that has more value and could be some type of additional payment for the quality or type of fat being sold by a dairy producer. So that's going to take some work and some convincing and demonstration of the value of that in terms of products, but it could be a lasting benefit in producing an attribute in milk that would have value in the payment system. There's many other activities that are carried out in the technology transfer. These are throughout the year. Our laboratory provides chemical and physical analysis rapid support to processors in New York State with troubleshooting for acute manufacturing problems and dairy product quality issues. These are chemical and physical product quality issues, not microbial. Some examples in the past year have been our work in the field with auto-oxidized off flavors and fluid milk and some consumer complaints through one of the co-ops in retail fluid milk. A focus on mechanical instability and poor whipping properties of heavy cream due to some issues in how cream is handled, cream separator operation, and so on, that we were able to trace as the cause of the instability. We also spent some time helping out with a eggnog product that was having separation problems. And there's been more interest by both selling and receiving plants for fresh cream, tanker loads of fresh cream, in terms of detection of added water in loads of cream, and also detecting a combination of fresh cream with whey cream. The funding from the New York State Milk Promotion Board enables us to provide this support to dairy processors in New York State. Along with our calibration samples, we also provide some support in terms of issues that happen with infrared milk analyzers applied to products and cheese making and in processing, and help with this during the time of COVID, where the instrument companies have been short-staffed and having trouble getting into the field with their service people. We've been able to help with some of that support for our New York State processors. I'd like to thank you for your support for this project, the technology transfer. It's an ongoing thing. If there's technology that our dairy industry is interested in, even if it wasn't something that was developed at our center in the Northeast, we want our processors in New York State to be able to implement technologies that are of value to them in the industry. If you have any questions, please send them to me by email, and I will be prepared to answer them at the March 1, 2022 meeting. My email is barbano1@aol.com. I thank you for your support and hope that this report gives you some sense of what we do in technology transfer. Thank you.